We'll still continue AC analysis, but the topic is phasor analysis. How to analyze AC circuits using phases, phasors or phasor diagrams. First, I'll try to introduce how the phasor diagrams of resistor, inductor, capacitor, and then combination of all of them, and then we will see different problems given in the exams. The first definition. Phasor analysis definition is: phasor is a quantity which has a magnitude, direction and rotation with respect to a reference. Please understand, phasor is not vectors. So it is neither a scalar nor a vector. We can treat them as a vector because it gives a direction in the form of an angle. So when angle is given, automatically it looks like a magnitude and direction. Then phasor analysis is one of the AC analysis techniques used for calculating output using phasor diagrams. So using phasor analysis, we draw the diagrams, and from the diagrams we calculate the magnitude and angle. Then third point to remember is every parameter having its magnitude and angle. By using this, we can draw the phasor diagram. So this is basic definitions in phasor analysis. Now let us see one by one. VI relationship with RLC. First I'll take with resistor. When you look at the resistor, the equation is V is equal to IR. Then what is the phase angle in this? Absolutely there is no phase angle. That means V and I are in phase. Okay? And therefore the phase angle is 0. When the phase angle is 0, cos 0 is 1. That's why we say unity power factor. Look at here. Suppose if I take I as a reference, or what is V? V is less than I because R is less than 1. If R is more than 1, V is more than I. Whether it is less than V or more than I, but one point is clear. The angle is 0. The value is changing, but the angle is not changing. That's the first thing to talk about resistor. Now let me take you to inductor. With inductor, V is equal to L di by dt. Then you must say, if we take Fourier transform, differentiation becomes j omega I. Therefore, V is equal to j omega I. What is the j omega? J omega means 90. Therefore, V is equal to j omega L into I into 90. So this is the angle. That means V is leading I by 90 degrees. So voltage across inductor is leading I by 90 degrees because this is leading angle. This is the explanation, circuit diagram. Voltage is given, inductor is here, current is taken. Then let's go to capacitor. When we look at the capacitor, V is 1 over C integral I dt. Integration of anything is 1 by j omega. Therefore, it is 1 by j omega. 1 by j omega means what? Minus 90 degrees. Therefore, Vc lags 90. Minus means lagging. So, if this is the reference, it is coming down. Lagging means negative side. Therefore, in a capacitor, voltage lags the current. That's the third one. Now individual components we have seen. Then what to do? We have to take combined components. Take for example RL. IR plus LDI by dt is V. If you look at here, VR, VL. R says in phase, VR is in phase, VL is 90 degrees. Now VR is in phase, VL is 90. If you combine, the overall will come. So what is overall here? This is the voltage. Overall voltage is equal to root of VR square plus VL square. Overall angle is root of j omega L by IR. Look at here. So if I take j omega L as the value for imaginary and then real value. So j omega L by R is the angle. Magnitude is root of R square plus L square into I. So that is overall angle is positive because inductor will always create positive angle. Then capacitor. In a capacitor, if you give the capacitor and resistor put together, this is VR plus IC. VR is on the x-axis, VC is negative. If we take the overall, it becomes magnitude of this under root. That means R square plus 1 by j omega whole square under root into I. Phase angle is 1 by j omega C by R. So 1 by omega RC. Like this, for any circuit, you don't need to worry too much about it. Get the expression. From the expression, imagine tan inverse of imaginary by real will give the angle, and magnitude of the each component will give you magnitudes. For example, root of x square plus y square will give you magnitude. Tan inverse of y by x will give us angle. So if you want to make the angle or magnitude, the best simplicity is make this real value plus imaginary value. If you convert the real value and imaginary value, the total overall will come. Let's see now. I am now coming to the last thing called all the three components put together. Look at here, there is a resistor, inductor, capacitor. I saw so many people and even some textbooks drawing all the three and then making the overall. But that's going to be a laborious one. What I suggest is, after all these are in series, VR is equal to IR, j omega L into I, 1 by j omega C into I. If you take all the three and draw the circuit, it will become complicated. As you see this case I am assuming VL is greater than VC. When VL is greater than VC, what will happen automatically? VL minus VC will become positive. That's why you look at here, VL minus VC I took and that with VR. So just like instead of handling as a 3 quantity, I am handling this as a 2 quantity concept. In that, one of the content is VL minus VC is get subtracted. So that's a very good idea for you to follow. Please follow this one. Now I will take you to the case where VL is less than VC. Look at this. With RLC, VL is less than VC. What will happen? Suppose VL is here, VC is more, VC minus VL, this is VC is more, so it becomes negative side. These two negatives you can, so negative value and this. Take the Phasor resultant. Actually, this resultant that I have been following, that is called triangular law of vectors. As I told you, vector and phasor is almost same. So therefore, if you follow the triangle law, it becomes the same, right? This is what I mean by theoretical thing. Now I am going to problems. So look at the problems one by one. In fact, there is so much of calculation involved. That's why I'll show calculations right on the screen and you follow it, because too much of calculations is required. Sometimes we need a calculator and solving with the calculator will take more time. So we will follow this style. Now problem 1. Calculate V by drawing Phasor diagram where omega is equal to 1. Look at the problem and read the problem. What happening here? Suppose this is a resistor, there's no problem about frequency. Inductor and capacitor always require frequency. You know what is it? For example, inductor is of course j omega L. If frequency is given, we can calculate. By mistake, if the frequency is not given, they have to calculate and give us. So 1 ohm, j omega, and so on. So this is the approach. Now what you do is calculate voltage across resistor, calculate voltage across inductor, add them vectorially or phasorly. That's the resultant going to happen. So just follow this. As I said, I am calling this as VR, this as VL. VR is IR, j omega L. What is R? 1. What is omega? 1. So it becomes 1 plus j altogether into I. 1 plus j into I. If you take magnitude, root of 1 square plus 1 square becomes under root. Then root 2 is the value. Angle is tan inverse of 1 by 1 because j is 1, 1 is real value. So imaginary value by real value 1 by 1. Therefore it is 45. If we see the Phasor diagram, we will understand this. This is 1, this is 1. Root of 1 square plus 1 square is 2. So these are the two answers required. Magnitude is root 2, angle is 45. Another serious observation I am telling you in AC, after calculating the magnitude and phase angle, look at the input, adjust those values according to the procedure. So by looking at these things according to the procedure, you can always estimate what is the overall. Okay, that's the answer. Now, second problem. Calculate V and draw the Phasor diagram if I of t is 2 sin 2t. Please understand here. This you can as well do without Phasor diagrams. But the Phasor diagram is required because he is asking it, otherwise it is not required. You can simply say this magnitude according to the real and imaginary values. Okay. Sin 2t. And if you look at here 4i 0.5, again understand very important thing here. What is the frequency? Frequency is 2. Use the frequency 2 there. In all this I am going to use IR 1 by j omega, that means 2 into 0.5, that's 1. 1 by j1 is 1 angle minus 90, and if you multiply those things, current is 2, 4 angle 2 because resistor is 4, 1 angle minus. What is 4 angle? 4 plus j0, 0 minus j1. So 4 into 0 minus j1. If you multiply that, you will understand this total value will come. So this is the answer for what you call the answer for the voltage he wanted. Because if you look at this amplitudes, the value is 2. 2 into 2 is 4. So calculate this one and then calculate this one, add them vectorially. Then if you draw the magnitude, angle tan inverse of 1 by omega c, and if you see the magnitude 10.2 volts, angle is tan inverse of 1 by c minus 11.3. So you put minus 11.3 means negative side, and the overall magnitude is 2 root 26 sin 2t, and the angle we have to keep. So this is how you can really solve this problem.